If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Good evening, everybody, and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, not to mention darn good friends of York University. I'll be one of your two hosts this evening. My name is Paul Delaney, and I am joined by Julie. Hi, Julie.
Hi.
We are broadcasting live from the York University Astronomical Observatory, located in Toronto, Ontario, Canada. And of course, this is Astronomy Night in Canada, where the lineup is entirely Canadian. Starting with ourselves, of course, York Universe, followed by Western Worlds, the Universe Today, Astronomy Cast, Quirks and Quarks, and even Science for the People. Lots of good stuff coming your way tonight, folks, so please stay tuned with us. York Universe broadcasts every Monday evening at 8 p.m. Oh, what am I saying? 9 p.m. local time here in North America, so that's at the moment Eastern Daylight Time. That's 1 a.m. Universal Coordinated Time for the rest of the world. So hi there to Black Projects. The York Universe production works in concert with our online public viewing program run by the Observatory team. And I can see at least Abteen and Siren over there. So hi guys. It runs from 8:30 through till 10 o'clock. So it marries up with our timelines here. By all means, point your favorite web browser to astronomy.blog.yorku.ca or, and this is the new one, observatory.info.yorku.ca. Both will land you in the chat room with wonderful pod images. There will unlikely be new images tonight, but who knows? We've had some really inclement weather here today. There's a lot of wind out there. They keep threatening thunderstorms. I'm not convinced that's going to happen, but it may not be clear enough for us to dare open the dome, so stay tuned. Our broadcast is powered by and in partnership with the Astronomy.fm, the voice of astronomy. If you've got any questions or comments you have about past shows or suggestions for future shows, by all means, send them through our blog, like us on Twitter, do the @YorkUniverse bit, and we'll be sure to receive that information. There we go, Julie. So, life is cool on your side of the ledger?
Sure. Sunny most of the time. It's summer. School's almost over.
Yeah. The school is almost over part. Not quite. We're almost halfway through the summer as far as the university is concerned, which means we're on the downhill slide to September. I begin to shake. Oh.
Yes, well, my school year runs with the elementary/secondary students. The secondary students have not been around the last little bit because they've been writing exams, but we certainly have had a lot of kindergarten through grade 8s coming through, a lot of end-of-year marathon trips to Toronto where they see every single attraction in 3 days.
Right. So you're looking forward to a little bit more downtime.
A little bit.
A little bit. Catch up with your email, I think you said earlier on.
Yes.
Fair enough. Well, whichever way we cut it, and we'll be talking about it in a few minutes, summer has officially arrived here in the Northern Hemisphere. But before we get to that, do you want to lead us off with This Week in Space and Astronomy History?
Sure thing. Okay, so June 20th, 1985, NASA announces the Cola Wars will take place on Space Lab 2. This was just one of many marketing campaigns between the longtime rivals Coca-Cola Company and PepsiCo. The soft drinks were launched into space aboard the Space Shuttle Challenger on STS-51F, which was Space Lab 2. Did I say Starlab earlier?
Yeah, that's okay. Yeah, it's a planetarium that you work with.
Within space. Anyways, it was launched on Challenger on July 29th, 1985. Both companies designed special cans officially called CBDEs, or Carbonated Beverage dispenser evaluation payloads.
Gotta love it. Gotta love it.
Right? In order to test packaging and dispensing techniques. Due to the lack of refrigeration and gravity, the shuttle crew deemed this experiment a failure, preferring Tang. Nevertheless, the Coca-Cola space dispenser was designed and flew aboard the Space Shuttle Discovery in 1995, in addition to the Coca-Cola fountain dispenser, which flew aboard the Space Shuttle Endeavour in 1996.
And I think it'd be true to say that there is no Coca-Cola aboard the International Space Station. At least I couldn't find any reference to it while I was snooping around on this story.
So funny. I think Coke won this one.
Well, I guess the fact that none of the astronauts enjoyed warm, carbonated beverages in orbit, I thought was the bottom line to the story. You know, they could mix the Tang up with cold water and was much more refreshing. But apparently the Coke and the Pepsi were equally underwhelming, shall we say?
Well, it's all the carbonation that I think I would want to deal with.
Can you imagine that squirting and spurting all around the place if you weren't careful?
Oh, just in my belly. I don't want carbonation left in space.
Fair enough. Yeah, what can we say? This was one of those things where obviously publicity was the name of the game, but none of the astronauts were particularly enamored with the process.
Oh, the 80s.
Yeah, do you pine for them? What can I say?
Not too much.
1985, my gosh. All right, well, moving a little forward in time, June 21, 2004. This was the launch of Spaceship One. It completed the first manned private space flight. I guess launch is not quite the right word because, of course, you drop it from an aircraft and then you light the rocket. So is that still called a launch? I don't know. Anyway, Spaceship One ended up winning the X Prize that year, which was a $10 million price tag. The actual flight on June 21st, 2004 was the 15th test flight of the vehicle, but it was the first time it actually reached space, which of course is defined as an altitude of 100 kilometers. The flight was made by pilot Mike Melville, the first non-governmental astronaut, and the 434th person to reach space. He actually flew two missions, this one and one other, and then he called it quits as far as the Spaceship One Corporation is concerned. There were big hopes, of course, that this would lead to space tourism with Spaceship Two by around about 2012, 2013. But as we both know, Julie, that has not materialized as yet.
Not yet. According to the Sky Guide, the folks doing launches from the aircraft call it an air launch.
So, okay, it's an air launch, not a
launch.
Launch. Yeah, okay, right. Well,
whatever.
Yeah, there's a subtlety there that I'll go with. But, you know, there were great hopes. I mean, this is Sir Richard Branson and so on, his big endeavor. I, for one, was hoping that we would have seen these suborbital flights by now out of the Spaceport USA, which is it Nevada or is it New Mexico? Somewhere down in that neck of the woods. But we are yet to see them on a regular basis, and so that's a little unfortunate in my opinion. It is New Mexico, not Nevada. So Spaceport USA, the home takeoff area for the Spaceship Two. You'll recall that they had that rather nasty accident about 18 months ago, which killed one of the co-pilots. So, yeah, things haven't gone as well as everybody had hoped for with respect to the Spaceship Two endeavors.
Yes.
Yeah.
But we don't do space because it's easy.
No, we certainly do not. And, so Richard Branson is persevering, and I dare say we will see it. And, of course, over the weekend, we even saw yet another player, Blue Origins, with their successful launch. So, yeah, the whole space tourism business is heating up. But Spaceship One, this day, June 21st, 2004, first time to reach the borders of space.
Very nice.
Okay, over to you.
All right, June 22nd, 2000, NASA announced evidence of present-day liquid water on Mars. They are using data from NASA's Mars Global Surveyor, and scientists were able to observe sources of liquid water at or near the surface. The features that looked like gullies formed by flowing water, and the deposits of soil and rocks transported by these flows were observed. Discovered on several Martian cliffs, the gullies appeared to be so young compared to nearby material that they are believed to have formed in the recent past, maybe even today. And the water supply was believed to be about 100 to 400 meters below the surface.
This is, of course, a story which has continued to have great traction over the last couple of years. The MRO observations have continued to show these striking linear features running down the steep inclines of craters and mountains. So there is continuing evidence, building evidence, that with the high level of salt which exists on the Martian surface, that this artesian water is in fact able to break through thinner areas on vertical faces, mix with the salt, and of course become a very briny liquid that erodes away these features. But of course it doesn't survive on the surface for very long, but it does survive for a brief period of time courtesy of the salt. So it really is an exciting development, one that I think 20 years ago people were not expecting, but now has received a degree of common acceptance.
Yeah, but still excitement. I mean, like the images, the most recent images, still got people excited, even
Oh,
though
no doubt.
we've known about this for a while.
Oh, absolutely, and it continues to be controversial. I mean, there are still people trying to figure out whether or not it really is salty water. There was, for the longest time, the belief that it just might have been sort of, the equivalent of rockfalls, dry rock that is sort of scooting down the surface of these very steep inclines. But the evidence really has been building courtesy of the new assets in orbit, spectroscopic assets, not just photographic assets, that what was creating these long linear features was in fact flowing water. Certainly a harsh environment though, Julie. I mean, you and I are not going to be able to go strolling around the surface of Mars anytime soon, despite what Total Recall might suggest.
Yes.
Good movie, or at least the original movie was. I don't know about the second one.
I have to admit I haven't seen it.
No. Okay. At any rate,
Most movies.
hats off to Mars Global Surveyor and the Mars Reconnaissance Observer for continuing the surveillance of the Martian environment. Stepping back a little earlier, June 24, 1982. This was an interesting day, and for those of you who are, wanting to keep the international flavor alive, this was the launch date of the first French astronaut. He was flying aboard a Soyuz T-6 vehicle, a member of the French military, General Jean-Luc Chrétien. It almost has a Star Trek feel to that every time I read that name. It really does.
It's a pretty powerful name.
Jean-Luc Chrétien. At any rate, the craft docked with the Salyut 7 space station. So this was in the early days of the Soviet Union and Russia's exploration of space station architecture. This was the Salyut 7 station. Things didn't go quite according to plan. There was supposed to be an automated docking, but it didn't quite work out that way. But they manually docked it without major difficulty. The onboard astronauts, cosmonaut crew, of course, carried out the usual types of low Earth orbit biological experiments, particularly antibiotic experiments in this particular instance. But Jean-Luc was the first French astronaut, and this was the first of his 3 missions in space. So there was this mission in 1982. He flew a second Soyuz a couple of years later. Then he joined NASA, and he flew aboard STS-86, which was Atlantis, in 1997. So he actually had quite a decorated career in space, a total of 3 missions. Not bad for a European astronaut. Unfortunately, sort of a bit of a sad take to the ending. He was forced to retire as an astronaut in 2001. He was stationed
and a drill press fell from a height of about 3 meters and hit him on the head.
He
was
lucky to
survive.
the first European, West
What is a
European,
drill
I
press
guess I should
doing at
say,
a height of 3 meters?
astronaut.
Well, I guarantee it's not there anymore.
Yeah.
He sued Home
Interesting
Depot.
stuff. So that was June
Because
24,
it literally drummed him out of the
1982.
astronaut
Yeah, that's
corps. He
34
survived
years ago.
the
You know,
impact,
I
but
didn't
not
realize
unscathed.
that we
And,
had
basically
a
his
non-astronaut career.
Russian,
So
very
non-American
unfortunate end to,
astronaut, cosmonaut,
the first
European, West
early
European, I guess
in
I should say,
the space shuttle era, the
astronaut.
early 80s.
Jean
Yep, he flew in
Chrétien.
1982.
Cool.
Interesting stuff.
Yeah. So that was June 24,
Next, couple of happy
1982.
birthday shout-outs,
that's
I believe.
34
Yes,
years
it wouldn't
ago.
be
You know,
show notes.
I didn't
with
realize that we
contributions from
had
Shaw without at least one birthday shout out.
non-Russian,
So June 24th,
non-American
1915.
astronaut,
Happy birthday
cosmonaut.
to Sir Fred
that
Doyle.
early in the space
he
shuttle
passed-
era, the early 80s. But, yep, he flew in 1982.
Cool.
Yeah. Next, couple of birthday shout-outs, I believe.
Yes, it wouldn't be show notes with contributions from Shaw without at least one birthday shout out. So June 24th, 1915, happy birthday to Sir Fred Doyle. He passed on August 20th, 2001. He was both an astronomer and a science fiction writer. Noted for his work on stellar nucleosynthesis, he was passionately opposed to the Big Bang Theory, despite being the originator of the actual name of the theory.
How's that for irony?
Yeah, I believe he said it as a joke. Though.
Yeah,
I'm not
be
mistaken.
careful what you say.
Yeah.
He said it on BBC Radio, so, you know.
Well, there you go. He also is one of the earliest scientists to suggest panspermia, the transportation of life by natural means from one planet to another. While he was well regarded for his popularization of science, his career was also noted for controversial positions he held on a wide range of scientific issues, some of which include the correlation of flu epidemics to the sunspot cycle, as well as a belief that the fossil Archaeopteryx, the earliest avian dinosaur, arguably, every now and then something new gets found and they're like, no, this is the earliest bird. But anyways, Archaeopteryx is a man-made fake, huh? Interesting.
Yep, this was all the way back in and around, I think, about 1985 when that controversy erupted. By the way, congratulations on pronouncing that fossil as well as you did. I was sitting there going, is she gonna? And you did. That was very impressive. Very impressive.
Oh, I teach at a museum.
I know, I should have realized that, but, you know, I was still impressed with the pronunciation. Just rolled off the tongue. At any rate, yeah, Fred Hoyle, for whatever reason, was absolutely convinced that Archaeopteryx was a fake. And he really went to town and had a couple of people sort of, you know, working with him to discredit the entire fossil. And, you know, reading through the accounts of it, it really is quite stunning for such a learned individual. I mean, he was slapped down fairly vigorously with all of the opposing evidence, or the confirming evidence, rather. Why he went out on such a limb on that particular one, I really have no clue.
Wow.
Yeah, very surprising. I liked his science fiction, by the way. I mean, there was some really neat science fiction. Some of the earliest SF that I read in the early 1970s was from Fred Hoyle. There was one in particular called The Black cloud, and it was a nebula that was meandering through space, and it kept doing course corrections and sitting itself in front of stars, and therefore blocking out the light to the various planets because it was sentient. And it was all about the attempt of humanity to communicate with it. Hey, move out the way! You're blocking the light. I mean, it was a really neat story.
That sounds fun.
Anyway, he probably wrote it in the 50s, but I didn't get around to reading it until the 70s. But yeah, quite an acclaimed astronomer, despite some, shall I say, eccentricity. I guess we're all up for a little bit of that periodically.
Well, we're all part of the odd squad, right?
Oh, very good indeed. Our Sky Guide will love that. Okay, our last item for this week in space and astronomy history, June 26, 1730. It's a happy birthday shout out to, you got it, your favorite frustrated comet hunter and mine, Charles Messier. He died, by the way, on April 12, 1917. That can't possibly be right, Shah. April 12, 1917? I think that's probably 1817. Okay, Shah, wherever you are, you blew that one. Messier was a French astronomer, most widely known for his compilation of 103 non-stellar objects, so galaxies, nebulae, planetary nebulae, star clusters. Anybody who's an amateur astronomer goes after the Messier objects with their very first telescope, their first set of binoculars. So it's got to be the most well-known 100 objects in the night sky. And obviously it's now known as the Messier Catalogue. The list was designed to help comet hunters distinguish between permanent sky features, that is nebulae and clusters, from transient comets. And that's what Messier was looking for. He was looking for comets, and he kept tripping over these other things that just wouldn't move until he knew they weren't comets. He was born in the Lorraine region of France and developed an interest in astronomy after seeing the Great Six-Tailed Comet in 1744 at the tender age of 13. Would have been quite the sight in non-light polluted skies of southern France. 7 additional objects, M104 through M110, are currently accepted to be a part of the official Messier catalogue, as they were believed to be observed by Messier from his notes or by his friend and assistant Pierre Marchand. In 1764, Messier was made a Fellow of the Royal Society, and his legacy lives on as his designations are still used by professionals and amateur astronomers today. Yeah, what a guy. I mean, really quite an amazing observer, a prolific observer, and even under such dark sky conditions, you've still got to be a meticulous observer, and that's exactly what Messier was.
Amazing. Have you done the Messier list?
Not all in one night, no. I think last count I've done about 60 to 70 of them, so there are a number that I have not seen, or at least I don't recall seeing them. I've certainly seen some of them, more times than I care to count, but no, probably only about 60 to 70% of the entire catalogue. What about you?
I've not seen all of them. I've not put the effort into seeing all of them. Most of the observing I've done has been from the Greater Toronto area, right? I started observing in Mississauga, did observing throughout university at York, and now I'm in Aurora, and there's it's light pollution and houses. Street light.
Yeah, I've seen lots of streetlights, yeah. I'm just having a quick look at the chat room. Tom has done the entire Messier catalogue. So my hat off to you, Tom. My gosh, it's quite an effort. It's well worth doing it. I've certainly known several people who have been successful in doing it, but you've really got to be dedicated. And it's well worth doing, but gosh, it takes time.
Yeah.
There was also one other little note from our earlier conversation about Spaceship One. The new Spaceship Two replacement was apparently rolled out in February of this year and is undergoing its flight test. So hopefully we will see Spaceship Two take to the airwaves again in the very near future. Good stuff.
If you've just joined us, folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the York University Astronomical Observatory. Julie and myself, Paul, are wandering through this week in space and astronomy history. Hats off to Shah, our colleague who can't quite make it tonight because he was instrumental in supporting the research for this evening. By all means, point your favorite web browser to observatory.info.yorku.ca. Join the chat room. Vigorous chat going on there. No new images are appearing, which suggests that it is in fact still cloudy down at the observatory. So a few observing notes, Julie. Happy summer.
Happy summer. Summer solstice at 6:34 p.m. EDT today. So it's been summer for
3 hours.
3 hours, give or take. This is, the solstices are like my favorite, but also least favorite days. Well, because it's like, yay, the longest day of the year, it's summer, and now the days start getting shorter. Oh, we're heading towards winter, and then we get to the winter solstice. It's like, yay, the days are getting longer, but it's still cold, and it hasn't been February yet. Anyway.
The circle of life.
Yes. Tonight's full moon is known as the strawberry moon, and it's the first time that it has coincided with the solstice since 1967. And for those of you who are wondering, strawberry moon? Ode
Yum,
Min-
yum, yum, yum.
Yeah, yeah. It is. It does have to do with fruit. It comes from the Anishinaabe. The word for strawberry moon in Anishinaabemowin is Ode Min Gizes.
Now, you wrote this, so I'm not helping.
I did. I may have just massacred the pronunciation. But it is the month in the Anishinaabe 13-month long lunar calendar in which the strawberry harvest occurs.
And that's the part that I like. Yum, yum. So there seems to be a name for every full moon of every month, and I have never seen them written out. I mean, we all know about the harvest moon and the hunter's moon in September and October, respectively. I can now add the strawberry moon, but have you ever seen all 12 months sort of itemized as far as their, quote, lunar designation is concerned?
Yes, I have.
You have. Okay.
I'm looking at it right now.
I was going to say, post the link.
Oh, I am going to post the link.
You can recite them as well.
OPV. This is the Anishinaabe ones, and so there are 13 because 13 lunar cycles in a year. This is from the Toronto Zoo Turtle Island Conservation folks, and so we have the new winter moon, the new moon of hard crusted snow, the sugar making moon, the sucker moon, the blossom moon, the strawberry moon, the blackberry moon, the blueberry moon, the corn picking moon, the gathering moon, the trout fishing moon, the hunting moon, the trapping moon.
Wow. Okay. So the corn one, because my wife was actually suggesting that one should be akin to August. Is that correct?
September. Blueberry is August.
Blueberry, I could really get into this. Very nice. Well, the important point, as far as we're all concerned, is that today is the summer solstice. And you remember, Julie, that you don't normally get full moons and summer solstices together. So, as you said, 1967, so that's what, 60 years ago? No, 50 years ago.
Sure, I'm not going to try to do math in my head.
Well, okay, 49 to be really, really picky. But, it doesn't happen often. Speaking of things that don't happen very often, this week, 2 years ago, June 23rd, so that would have been June 23rd, 2014, was our 200th episode of York Universe. We are at, I think it's 278 for tonight, Julie? Yes, 278. Yep, yeah, it is 278. Right. We are on the countdown to 300. Whether or not we're going to quite make 300 this calendar year, it's going to be really, really
tight because we've just found out that we're not actually doing an episode on July 4th. Everybody's going to be partying furiously that night, so there won't actually be a new show on July 4th. But our 300th episode is certainly on the horizon. Might just sneak it in before the turn of the new year. But we've been at this for quite a while, kiddo.
Yes.
Yes,
which is
indeed.
awesome.
Yeah, no complaints
I
about
can tell
that.
you how long it's been because it started the same year my first daughter was born, and she is now 7.
There you go. So 2009, the International Year of Astronomy.
Mhm.
Yes.
Well, I was making little astronomers that year, so
yeah.
didn't get to do a lot of astronomy.
First of 2.
Yes.
Sounds good. One other little item here, and I'll leave that one to you.
You'll leave that one to me because it's congratulations to you, Paul.
I didn't put it in here.
Nope, I did. I saw it on Twitter this morning. The Dean of Science at York, Dr. Ray J. His last name's really long. We just go with Ray J. I'm sure you can pronounce it though, Paul.
Joanna Dana.
Anyways, he tweeted it this morning, and I was like, definitely have to include this. So Paul has been appointed a university professor. That's university and professor with capital P's, and they are awarded to long-serving tenured faculty members who have made an extraordinary contribution to York University as a colleague, teacher, and scholar, including significant long-term contribution to the development or growth of the university or its parts, significant participation in the collegium through mentorship, service, and or governance, sustained impact over time on the university's teaching mission, and recognition as a scholar. And I have to say it is well deserved, Paul.
Thank you very much, Julie. My Twitter has been twittering all day. I kid you not, it's been a wonderful day in that regard. The actual ceremony is on Thursday for our convocation, where I will be joined by all of the graduates of the Faculty of Science this year, including one of our co-hosts, Richard Block. He will be strolling across stage as well on Thursday. So, yeah, it was a good day. It's going to be a good week, and it's 30 years come September since I arrived at York.
So you started when you were 10?
You're good. You're really good. We'll hold that thought. We'll say I was younger at that point in time than I am now. September 2, 1986 was my first day at York.
Oh, very nice.
Yes.
That was my birthday.
Really? September 2?
Mm-hmm.
There you go.
I won't tell you how old I turned.
No, well, well, we could go with a few, right? We'll just go with
digits.
A few. Single digits, that's right. Excellent.
I have posted a link to the York News, the Wi-Fi news article to the OPV if anyone wants to look at the laundry list of all of Paul's accomplishments in the 30 years he's been at York. It has been sorry, my youngest just walked in. It's a pleasure working with you, Paul, and hanging out with you. And you were a very important part of my undergrad experience. So thank you.
Pleasure was all mine. Absolutely. Thank you for the kind words. Moving right along here to other rather important news. There is a small asteroid in Earth's vicinity that is a relatively constant companion. Well, the term Earth companion can be dated back to around about June of 1997, when astronomers from York University and Turku University in Finland characterized the orbit of an asteroid, beautifully named 37653, or 1986 TO, and yes, it did not be associated with Toronto, to be heavily influenced by not only the Sun, but by us, the Earth. The asteroid never ventures closer than 15 million kilometers, but it can be as far as 375 million kilometers, orbiting the Sun at essentially the same distance as the Earth. Kim Innanen, Paul Weigert, who is now at the University of Western Ontario, and Seppo Mikkola, I was
drawing a blank there on Mikkela's first name, Seppo Mikkela, performed numerous orbital simulations to match up with the observed orbit of this particular asteroid. And they came to the rather startling conclusion that it was, in fact, being gravitationally controlled in part by the Earth. As Innanen said at a press conference in June of 1997, the asteroid's behavior was fickle, with it performing what could best be described as a horseshoe orbital dance around the Sun in the orbit of the Earth, as seen by us here on the Earth. Well, since that time, there have been numerous studies of the region near Earth, checking out, whether or not other companions existed. Asteroid 2003 YN107 followed Earth for a number of years in the late 1990s, early 2000s, but has since departed our vicinity. Well, now the Hawaiian Pan-STARRS-1 asteroid survey from the Haleakala Observatory has found another companion, or a quasi-companion, 2016 HO3. It's pretty darn small, probably less than 100 meters in diameter compared to the asteroid that Innanen and company were working on. That was about 10 kilometers in diameter. 2016 HO3 is in quite a stable orbit. Its dance, if you will, is likely to exist for hundreds of years compared to 2003 YN107, which has, as I said, disappeared. It spends about half of its orbital year, and its orbital year is almost exactly that of a year because its mean distance from the Sun is the same as the Earth, but it spends about half of its year in front of the Earth and about half of its year behind the Earth. So basically, if it gets in front of the Earth, it's traveling a little bit faster. The Earth's gravitational field sort of pulls back on it. It drags it behind, and then it slips a little bit further out from the Sun, and then again the Earth grabs it and pulls it forward. And so this yo-yo seesaw action happens throughout the course of a year. The orbit is inclined slightly, so the asteroid itself appears to bob up and down. So it's not in the ecliptic plane. It bobs a little above it, a little bit below, as it wanders around the Sun. It's a really interesting object, needless to say. A guy by the name of Paul Schodas from NASA's Near-Earth Observation Office suggests that it will remain in the vicinity of Earth for the better part of many, many centuries. So all of this started back, if you will, in the 1980s and 1990s, and we continue to observe this region of space continuously.
That is so cool. I love how you can just pull these York connections in.
Well, I remember the press conference well. It was in 317 there in the Petrie building. We've never had as many media with such a keen interest. It was a good decade, so to speak, because Marshall McCall was in the same spot 2 years prior as they were announcing the existence of some very nearby companion galaxies in the local group. They had developed a technique which would look through the plane of the galaxy and then basically get rid of all of the stars and see what was on the other side of our galaxy, but in the plane of the galaxy. It's a really quite revolutionary technique. So, Kim, not to be outdone, worked with Paul and Seppo, and they found this really interesting horseshoe orbit. And as I said, since then, there's been a lot of work done. Paul Weggett continues this work at Western, as does Seppo Mikkela in Finland, working on these really unusual orbits. They're not exactly Trojan asteroids because, of course, we're familiar with Trojan asteroids orbiting in the same orbital path as Jupiter, 60 degrees in front, 60 degrees behind. There are Saturnian Trojans. They've even found Martian Trojans. Well, these companions are not exactly Trojans because they really do get quite close to the Earth, but nonetheless, it just shows you that orbital dynamics in our solar system can turn up some really unusual characters.
So cool.
So cool. Very good indeed. All right, so there is our Earth quasi-companion. Don't rush out with your telescope and try to find the darn thing because, it's a little small and a little faint. But, quasi-companion. Earth companion.
Cool.
Okay, speaking of cool,
Gravity waves are back in the news, Julie.
Hooray, more gravity waves. So in February of 2016, which, gosh, really hope that wasn't the last time I was on, but it feels like it might have been. The Laser Interferometer and Gravity Wave Observatory, LIGO, announced its first detection of gravity waves from the merger of two massive black holes. They were 36 and 29 solar masses, which were things that we had not observed yet. Anyways, they merged 1.3 billion light years away, and they were detected on September 14th of 2015. So the strength of this merger sent gravity wave ripples through space-time and confirmed the theory first postulated by Albert Einstein 100 years ago. The two LIGO detectors in Louisiana and Washington states are the most sensitive detectors on the planet, and we're easily able to see the ripples that caused a tiny deformation in the mirrors of the detectors. During the Christmas break in December, so just a few months after, there was a second detection, coincidentally at about the same distance, 1.4 billion light years, but this time two smaller black holes. This time it was 14 and 8 solar masses, and its pairs being referred to as GW 151226 because astronomers are very creative with naming objects. Anyways, they coalesced, and while there's no doubt about the authenticity about the signal, it is much weaker than the first detection. The first detection was really like boom, you could like see it. This one was more lost in the noise. So interestingly, both detections have come from black hole mergers, which was something of a surprise given that the thought had been that neutron star mergers would be more common. None have been observed so far that we know of. Of course, such mergers may still be occurring at higher frequency, but they're much harder to detect, and so that may be the next challenge for the next generation of LIGO detectors.
Stay tuned, indeed. I mean,
Yes.
the first run with the LIGO detectors out of Washington State and Louisiana has, I think, now stopped. It was meant to be something like an 8-month run, and it started September of last year. So it probably, if it hasn't shut down now, it certainly will be shutting down. They're sifting through the data, looking for these neutron mergers. But when they restart, and I haven't actually heard when the restart date will be, the detection sensitivity they expect will be even higher, which to me is just stunning, because we're talking about just about the diameters of atoms. That's the level of deformation that we're detecting on these mirrors. It's really a stunning piece of technology. So how you actually increase that even more is mind-boggling to me. But that's what they're talking about, and they're talking about a new detector in Europe, and I believe even a detector somewhere in South America, or at least in the southern hemisphere somewhere. Between the 4 detectors, they will then have the ability to localize where these events are occurring in space with even greater precision. When the mergers are taking place and when the LIGO detection goes off, there's a bit of a flurry of activity to try and point all sorts of other telescope and other assets towards that area to try and have follow-up observations at differing wavelengths. The September observation, I believe, had some form of confirmation from the Fermi satellite, if memory serves.
Yes.
Is that what it was? Okay.
Mm-hmm.
So, I mean, there is much to be said for getting simultaneous or as near simultaneous observations at different wavelengths as you possibly can. But this is a really exciting new branch of astronomy, one that I wasn't at all convinced I was going to see in my professional life.
Yeah, they missed the opportunity to observe in other wavelengths or in electromagnetic spectrum because of the timing of this one, because it was right at like Christmas or the 26th of December. And so all the LIGO team members got texts and, ran away from their family gatherings to hide out in empty bedrooms with their laptops because this was all very secret. The next step to go to the broader astronomical community is not automated, so that didn't happen just because of the, it was
timing.
Time of the year for many people.
Very inconsiderate of those two black holes. I mean, come on, really.
Well, yeah, those were harder to pick out as well. Inconsiderate black holes. Don't you know what's going on here?
Exactly. Yeah, delay a day or two.
Stuff. Yeah, they're harder to pick out as well. They have basically supercomputers trying to pull out signals from models, like comparing the signals coming into models based on theory out of the noise that they're getting, because the Earth is a noisy place when it comes to gravitational waves. Vibrates quite a bit, and the comparison that I read about was comparing it to the app Shazam. For anyone who is unfamiliar, the Shazam app, if you're like, oh, I love this song, but I don't know what it's called, I want to know what it is, you play it into your device and it will match up what it's hearing with a database and tell you, oh, it's this song by this person. So same idea, but with black hole mergers.
Not half bad. I mean, when all is said and done, as I said, I didn't really expect gravitational wave astronomy to be a significant part of our observational arsenal in my professional lifetime, and yet here we are. It's really great. It took us 100 years to verify Einstein, but it just goes to show you, how cluey was that guy? I mean, really.
The other thing that's crazy about this is now, how often do these mergers happen? In the universe, it might be a few per hour.
Yeah, now I saw that quote somewhere, and that to me is really amazing. Really does suggest how big the universe is. If you're talking about having a binary star system that deposits two black holes, and they're merging at the rate of a few per minute, to me that's quite mind-boggling. It really is. So that will be the next stage. I mean, just like exoplanets, we found one in a month, and then we found another one, and after a year we'd found half a dozen, and now we're finding them better than one a week. It's almost one a day, and so on and so forth. The same sort of thing is probably going to happen here with gravitational wave astronomy. We're finding them relatively slowly at the moment, but once we perfect the technique, we will begin to find them far more quickly. And black holes, if they're speculating them to be a few times a minute, I shudder to think how many neutron stars are doing this dance, this death spiral per minute, because they must be more common than black holes.
Yes.
Exciting
time.
It certainly is. All right, well, let's move a little closer to home and into an arena which us stellar astronomers are a little more excited about. There are a whole lot of unexpected gas giants hiding in a nearby star cluster. They are shy. What can I say? Using a number of telescopes and instruments, including the HARPS spectrograph, that's a really, really important spectrograph in the exoplanetary exploration community. The HARPS spectrograph at the European Southern Observatory, ESO La Silla Observatory in Chile, a Chilean, Brazilian, and European team of astronomers has found that there are far more hot Jupiters than expected in a cluster of stars called Messier 67. There you go, Messier 67. We spoke about him earlier and so on. M67, in fact, is what our fourth-year students observe on a regular basis for our 4270 course. Michael de Robertis gets them to do a lot of really neat stuff with Messier 67. I digress. Hot Jupiters, of course, are very large, massive gas giants like Jupiter or much larger, and they are circling their parent star much closer in than the orbit of is Mercury, say, to our own sun. hence the term a hot Jupiter. We found lots of them in the early going of exoplanetary exploration. 51 Peg B, for example, was a hot Jupiter. That was the first exoplanet found. The denser environment in a cluster causes more frequent interactions between planets and nearby stars. Not a surprise there. If you've got a lot more stars packed into a volume of space, there is going to be more gravitational engagement, more gravitational eddies, and so on. And it is this which we suspect is explaining the excess of hot Jupiters. A giant exoplanet orbiting close to their parent stars with an orbital period of less than 10 days is the, in fact, definition of, shall we say, a hot Jupiter. It gets much further out and it gets cold. Not really. Okay. It was led by Roberto Sanglia of the Max Planck Institute for Extraterrestriische Physik in Göttingen, Germany. Yeah, I murdered that. What can I say? I was more or less close. Okay. And Luca Pasquini from the European Southern Observatory. They have spent several years collecting high-precision measurements of 88 stars in M67. This is an open cluster, albeit a very old open cluster, is about the same age as the Sun, so 4.5 billion years or thereabouts. And it is thought that the solar system arose in a similarly dense environment. The team used HARPS, along with other instruments, to look for the signatures of giant planets in short orbits, short orbital periods, hoping to see the telltale wobble, so radial velocity technique, that a star is subjected to because of the presence of a nearby planet. So in other words, really massive planets close in have the most profound influence on their parent stars, exaggerating the wobble and therefore generating this Doppler red and blue shift of spectral lines in the star's spectrum. That signature has now been found for a total of 3 stars in the cluster, alongside earlier evidence for several other planets. The study found that hot Jupiters are more common around stars in M67 than is the case for stars outside of the cluster. 5% for the M67 stars studied, compared to studies of stars not in clusters where the rate is closer to 1%. So we're suggesting that there might be as much as 5 times greater presence of hot Jupiters inside this open cluster M67. It is thought that they formed further out, so the planets probably formed further out from the stars, as our own Jupiter most likely did, and then moved closer in its orbit around the parent star. What were once distant, cold giant planets, because out in the outer solar system, of course, it is a much colder, cooler location, these giant planets are now much hotter by virtue of their proximity to their parent stars. Though there are a number of possible other answers as to why. The authors conclude that this is most likely the result of close encounters with neighboring stars, or even with the planets in neighboring solar systems, so gravitational interactions planet to planet from differing stars because of their relatively close proximity, and that the immediate environment around a solar system can have a significant impact on how it evolves. Now, if you think about it, the nearest star to the Earth, Proxima Centauri, the Proxima Centauri star system, Alpha Centauri, and so on, 4 1/3 light years away. The distance, the average distance between stars in clusters is much, much smaller than that, sometimes less than a light year separation. So, when you think about that in 3-dimensional space, the volume density of stars much higher in clusters than it is, say, for example, in the outer spiral arms of the Milky Way galaxy. The authors conclude that this is the most likely the result of close encounters with neighboring stars, or even with the planets in these neighboring solar systems, and that the immediate environment, I read that, didn't I? So I should stop. Yes, I'll stop that. I thought I got sidetracked, and I'm going, just a minute, I've said this. So an interesting result showing you that cluster environments and spiral arm environments can in fact produce some very differing types of solar systems, which, given what we found in the mid to late 1990s, shouldn't really surprise us too much at all.
Cool. Is this the first open cluster that's been studied this way?
To the best of my knowledge, the answer is yes. But exoplanetary studies, as you well know, Julie, are only 20 years old, and
Yes.
only in the last 10 years have we found literally thousands of exoplanets, aka since the time of Kepler.
Yeah.
So my bet is that this is likely the first study of its kind, but it will not be the last.
Cool. So more clusters studied, more percentages coming at us.
Absolutely. More statistics, whether you like it or not. I think we've got time for Tatooine, don't we?
All right, yes. So sticking with exoplanets and Kepler, researchers have found the biggest planet orbiting a double star yet, hence the Tatooine reference. So this one is Kepler 1647b, and it is located 3,700 light years away in Cygnus. It is a Jupiter-like planet orbiting in the habitable zone of its stars. The geometry of a binary system makes the transit method trickier than usual. With a single star, as many of you out there know, you get a regular dip in the brightness of the star as the planet passes between it and us. Binary stars complicate things enough that sometimes the signal isn't even periodic. Amateur astronomers from the Kilodegree Extremely Little Telescope, or KELT, follow-up network in South Africa helped by performing follow-up observations from Earth, leading to an estimate of the planet's size. So Kepler 1647b is about the size and mass of Jupiter and takes a little over 3 years to orbit its stars. And the team looks forward to using the TESS, which is the Transiting Exoplanet Survey satellite, scheduled to launch next year, to find even more of these planet systems around binary stars.
I love the title Tatooine. I really do. I mean, for the longest time, we were not at all convinced that planets could exist around binary stars. And now we are finding, quite a good number of them. I mean, the constraints, the gravitational constraints on a planetary orbit around a binary star, much more significant, much more extreme than just, a planet orbiting around a regular star. But as I said, when I was going through grad school, we didn't think it could happen. We just didn't think stability could be maintained. And here we are talking about a multitude of Tatooine planets.
Heck, even when I was doing my undergrad, it was still, I don't know about this.
Yeah, that's exactly right.
Yeah.
The 20 years of 21 years of exoplanetary astronomy have really been quite the roller coaster ride, and a lot of it, we can put down to the influence of Kepler, which launched in 2009. I mean, it's been a stunning 7 years, if you will, courtesy of the Kepler satellite.
Yes, it's amazing. And there's still probably tons of data to go through there, I assume.
And of course, it's continuing to operate. I mean, that's the other good news story about Kepler. Even though it went down in 2013 when its second of 4 reaction wheels failed, the remaining 2 are still functional and operational quite happily, it seems, and they're into the K2 mission now, using the solar wind to help stabilize the spacecraft. So we've often commented that satellites have an uncanny ability to live much longer than their intended lifetimes would have suggested. Well, Kepler is carrying on that proud tradition,